The next topic from the chapter motion is equation of motion by graphical method. Over here they have considered an object moving with a straight line with uniform acceleration. From this they have derived three equations. Over here they have considered an moving in a straight line with initial velocity u, as I have shown in a diagram. Then final velocity v. Over here time taken to cover a distance is denoted by t, that is OC and AD is equal to t, whereas OA and CD is equal to u, whereas AB is the distance traveled by an object. Over here, with the help of all this, we will derive the three equations. The first equation which is derived is shown as v is equal to u plus at, where v is the velocity, final velocity, u is the initial velocity, a is the acceleration. This equation is called as an equation for velocity time relation. The second equation is distance s is equal to ut plus half 8t square. This equation is for the position time relation. The third equation is 2as, which is equal to v square minus u square. This equation is for position velocity relation, where s is the displacement, t is the time and a is acceleration. Over here, how to derive the first equation, that is denoted by as. They have considered by the definition of acceleration. We have before seen what do you mean by acceleration. Acceleration is the change of velocity divided by the time divided by the distance traveled by an object. Once again I will repeat it. Acceleration is defined as rate of change of velocity divided by distance traveled by an object. Over here they have considered acceleration is equal to velocity, final velocity minus initial velocity divided by distance. With the help of now we can derive the first equation by the definition of acceleration. Over here, equation of velocity time relation. Over here they have considered an object moving with an uniform acceleration, where u they have taken an initial velocity, that is OA is an initial velocity and final velocity is dB. By the definition of acceleration, we know what is the definition of acceleration. Acceleration is defined as rate of change of velocity divided by distance. So it can be written as acceleration is equal to final velocity minus initial velocity divided by distance. Over here final velocity is BD minus initial velocity is OA and distance is OB. As I have shown in the graph in the picture, BD is equal to V. We can write in the place of BD V minus OA is equal to U. We can write O in the place of OA U divided by OD. OD I have written as T. Therefore, A is equal to V minus U divided by T. Now we can move T in the numerator place. That can be written as which can be simplified as AT is equal to V minus U. Therefore, it can also be written as AT plus U, which is equal to V. When you change the place of from minus to the next side, left hand side, that minus U will become plus U. That can be written as AT plus U, which is equal to V. Therefore, we can get the first equation as V is equal to U plus AT. Now, if we want to derive an equation for position-time relation, over here they have considered an object have travelled a distance s in time t under uniform acceleration a. As I have shown in the figure, I have denoted all the term values. Over here, OD is equal to AC, which is equal to t. Then OA is equal to CD, which is equal to U, that is the initial velocity. Then if we want to find out the distance travelled by an object is equal to area of an trapezium, that is distance travelled by an object S is equal to area of trapezium AODB. Now, area of an trapezium is being divided into two parts, that is area of an rectangle AODC plus area of a triangle ACB. Now, you just recall what do you mean by area? What is the formula for area of a rectangle? Area of a rectangle is equal to length into breadth. Over here, the length of a rectangle AODC is, the length is OA and the breadth is OD. Now, the area of a triangle, a formula for area of a triangle is half base into height. Now, over here I have given half into AC. AC is T and BC is the height. AC is the base and BC is the height. That can be written as downside AS is equal to U into T plus half into T into BC. What is the value for BC? I have found it upside. We are having the value of BD and CD. We can find the value for BC. So, BC is equal to V minus U. Now, you will put the value of BC as V minus U in the place of BC. Then the equation will be as S is equal to U plus T U into T plus half into T into V minus U. Just refer the page while listening. That I have given equation number 2. Now, we know that acceleration is equal to V minus U divided by time. Okay. Therefore, it also can be written as AT is equal to V minus U. That is the first equation. Now, we are going to put the first equation, that is the value of V minus U is equal to AT. This value of V minus V minus U we will put in the equation number 2. Then the equation 2 can be written as S is equal to U plus T U into T plus half into T into AT. Finally we will get the second equation, which is derived as S is equal to UT plus half AT square. Yeah, the equation for the position time relation. This is the equation 3rd, which we can derive from the graphical method. let us consider an object have traveled a distance s in time t under uniform acceleration. As shown in the figure, the distance traveled by an object is obtained by the area of the trapezium, that is, can be also said as distance traveled by an object, which is equal to area of trapezium OABC. Now, what is the area of a trapezium? The formula for area of trapezium is equal to half into sum of parallel sides into distance between the parallel side. Now, over here the trapezium which I have shown you, that is OABC, the parallel sides, which are the parallel sides in this trapezium? It is OA, and the next side is parallel side to OA is BD. Now, these two are the parallel side, that is OA and BD. Then the next is, what is the distance between the parallel sides? The distance between the parallel side is OD. The two parallel sides OA and BD, the distance between them is OD. Then we can write as S is equal to half into AO plus BD into OD, which can be again simplified is equal to S is equal to half into U plus V into T. That is the first equation, okay, where the value of AO is equal to U, that is initial velocity, then BD is equal to final velocity V, and OD is equal to T. Now, over here we know that acceleration is defined as final velocity minus initial velocity divided by time. Therefore, it can also be written as T is equal to V minus U divided by A. Now, we can put this value of T in the first equation. Then the first equation can be simplified by putting the value of T is equal to S is equal to half into U plus V into, I will put the value that is V minus U divided by A. Then this equation over here, we will take 2 and A on the left hand side. Therefore, the equation as I have written over there can be simplified as 2AS is equal to U plus V multiplied by V minus U. That can be again further simplified as 2SA is equal to V in the bracket V minus U plus V in the bracket V minus U. Therefore, 2SA is equal to UV minus U square plus V square minus UV. Then we can cancel UV and minus UV. Okay, therefore finally we will get the last equation, that is 2SA is equal to V square minus U square. Now, uniform circular motion. For this, you will consider one example. Suppose an object is moving in a closed path. For example, as shown in the figure 8.9, they have shown the four types of tracks. The first track is a rectangular track. The second is the hexagonal track. The third is the octagonal track. And the fourth is the circular track. Now, If a object is been moving in this direction, so he have to change the direction. For suppose for rectangular, he have to change his direction 4 times. Suppose for hexagonal, he have to change the direction suppose 8 times. Suppose octagonal, he have to change the direction for 10 times. And suppose it is a circular path, then it is observed that number of sides of an track increases. Then suppose if you will take an example of an athletic who is running on that circular track. It is observed that if the track is circular, then the number of sides of a track increases. The athletic have to take turns more and more oftenly. Why would it happen? Why? Because the track is in a circular manner. If you do this, you will notice that the shape of the track approximately the shape of a circle, and so the length of each of the side will decrease to a point. If the athletic moves with a velocity of constant magnitude along a circular path, the only change in his velocity is due to the change in his direction of motion. Then we can derive the velocity. Is given as circumference divided by time. The circumference of a circle of radius r is given by 2 pi r. We have studied what is the circumference of a circle. The formula for circumference of a circle is 2 pi r. Suppose if the athletic takes the time t to go along a circular path of radius v, then the velocity can be derived as v is equal to 2 pi r divided by t. Now, what do you mean by uniform circular motion? The definition of uniform circular motion is when an object moves in a circular path with uniform velocity is called as an uniform circular velocity. Yeah, I hope that you have understood this chapter. In the next clip, I will give you the question answers which are remaining. If you may have any doubts, ask on my WhatsApp.